Okay, so you can try this up on the whiteboards. There are cards in my desk for you to do some random groups, but we'd like you to head up the whiteboard and try and solve for this equation. This is based on the stuff we did yesterday, so you can push pause on the video and give you some time to do it, and then we'll come back and take the answer up. Okay. So this one looks like just a simple solving equations type thing. If you can imagine off to the side, this might be helpful for you to think of this as 5x plus something like a number equals 3x. And we know we'd want to subtract 3 from both sides and bring this over. So I know how to solve this. It's like a linear statement. So I want all the coses on one side, so that's going to make it 2 cos theta, and take this over is negative root 3. And then I want cos theta by itself, so cos theta equals negative root 3 over 2. And then we'll go through our process, ask ourselves the questions. So we're going to ask, when is cos negative? We'll come over here and draw our picture. And from the cast or Astica rule, we know that cos is negative in the first, no, not the first. It's everything's positive there. It's negative in this quadrant and this quadrant. And so we know there's one answer in standard position that goes here, and a second answer that goes all the way over here. We could get some help or guidance from our calculator. So the calculator in degrees would spit out 150. That's just guidance, remember? That could be one of our answers, and it turns out that it is. 150 is this red one. So I know that that's one of my answers. Or it could be the other one. Well, if that's 150 from here to here, then that means that we have 30 left over as the radius acute angle. That means that's 30. So this is 180 plus 30 is 210. It's easier to think in degrees, but we need to actually answer in radians because that's what the question asks for. And so we got to convert it back to theta being, well, again, think of this as 30 degrees is pi over 6. And so if that's pi over 6, then the first one must be 5 pi over 6. And if it's pi over 6 past 180 or past pi, 6 pi over 6 gets us to pi. So one more is 7. And we get 7 pi over 6. And so our answer is the solution set theta equals 5 pi over 6. And 7 pi over 6. And in general, we've got 5 pi over 6 plus 2n pi, and 7 pi over 6 plus 2n pi. So that's just a recap of what we did yesterday. And we're solving equations yesterday and use this little process to get our answer. So how is today's lesson going to be different? Well, I call this a linear quadratic equation because you see there's no cos squared, it's just coses. So you can solve it linear like you would solve a linear equation, put the letters on one side, numbers on the other side, and solve. Today's lesson is on solving, oh sorry, I'm going to skip that one. Solving quadratic trig equations. So to solve quadratic trig equations, we of course have a different strategy. Solving linear, you put letters on one side, numbers on the other side, but solving quadratics, we set equal to 0 and factor. And again, think about what you know. Imagine or think about this question as 2x squared minus x minus 1 equals 0 instead of 2 sine squared and sine x. Just imagine that it was this. Then we know how to solve that. Okay, you can use TV tray or any of your methods to solve. So 2, 1, 1, 1. I need a negative 2, so 2 and 1. So that's going to be negative 2 and 1. So this is going to factor to 2x plus 1 and x minus 1 equals 0. So instead of, I use that just because to make it look familiar, but now then I'm going to actually factor this using the signs, and it's not 2x, it's 2 sine x plus 1 and sine x minus 1 equals 0. And again, think back to what we would have done had this been a regular quadratic one. We'd set this equal to 0 and say x is a negative 1/2, and set this equal to 0 and say x equals 1, and we'd solve from there. Well, same idea here. We got to set this equal to 0, so 2 sine x plus 1 equals 0. Subtract 1 from both sides and divide by 2. Sine x equals negative 1/2, just like what we had here. And this, sine x minus 1 equals 0, adds 1 to both sides, and we get that. Now, what we've done is we've created two smaller questions, just like the ones we did yesterday. We have to solve for x in each of these. So we go through and ask ourselves the same questions we did yesterday, just like its own little question. So when is sine positive? In my picture, sine is positive in the first and second quadrant. So I have two answers. One is going to be right here. The other is going to be over here. I go to my calculator for advice. Calculator says, I type in negative 0.5 second function sine. Calculator tells me negative 30 degrees. Again, I have to interpret what the calculator is trying to tell me. Oh, wait, I'm sorry. I've made a mistake. My apologies. Sorry about that. Maybe you were yelling at the screen, which is good if you were yelling at the screen. Because I said when is sine positive, but it's clearly negative right there. So when is sine negative? So sine is negative in this quadrant and this quadrant. So one answer is going to be here, and the other answer is going to be all the way around. Now, I'm not too upset that I made that mistake, because you might make that same mistake, and I knew that something was up when I turned to the calculator for advice. So remember, the calculator spit out negative 30 in my old picture. That didn't make sense, but now you can see that negative 30 does make sense. It's right there. That means that this is 30. So I can do 180, takes me halfway around, plus 30 more, and that's going to be 210. So theta, or I guess x in this case, x is 210, or the blue one is 360 all the way around, but take away 30, so 330. Again, know that this is pi over 6, and this is pi over 6. Pi is 6 pi over 6, so for the green guy, I'm going one more, so it's 7 pi over 6. And the blue guy is going to full pi, or full rotation would be 2 pi. In 6s, that's 12 pi over 6. One less than that makes it 11 pi over 6. So everything here on from the red and the green is all exactly like yesterday. We just had to do that small little step at the beginning. Now, I've got 2 answers, but those are all the situations when I get this, or more specifically, when sine x equals -1/2. I can't forget about that this is an option too. So the question is, when is sine equal to 1? Well, this is a special one because sine equal to 1 isn't in a triangle. You can just imagine the graph. So let's think about the sine curve. Because 1 isn't in any quadrant, the sine curve goes like this. When is sine equal to 1? Well, it's right there at 90 degrees. 90 degrees, or in radians, pi over 2. There's no other spot where sine is equal to 1. There's a spot where sine equals -1, but no other spot where it equals 1. So something like sine theta equals 1, we're not going to do that whole rotation thing because 1 is not in any of the quadrants. We're just going to look at the graph and say, oh yeah, that's there. You could have other questions where it's saying, when is sine theta equal to 0? Well, I don't need the picture for that one. I'll just use the graph and get the 3 answers right away. All right, now I got to wrap it up and actually answer this question. So again, I haven't put it up here, but this is the same thing. We want to do between 0 and 2 pi, and then we want to do it in general. Sorry. So for the first one, we have 3 answers that are going to work. So 7 pi over 6, x equals, let's make the solution set. X equals 7 pi over 6, 11 pi over 6, and pi over 2. Since it's a solution set, it doesn't matter what order we put them in, as long as they're listed. And then, of course, each of these are going to repeat every 2n pi. So 7 pi over 6 plus 2n pi, 11 pi over 6 plus 2n pi, and pi over 2 plus 2n pi. There's the general statement.